So hello everyone, welcome back to the channel. Today we are going to solve the really interesting problem, string RP or PR. So given a string S, in one operation you can remove substring PR from the string and get the amount X, or you can remove RP and get the amount Y. So we have to find the maximum amount in 0 and more such operation. So let's discuss the question with an example. Let us consider we are given this test case. So first we understand what is X and what is Y. X is the amount that we get when we remove PR from the string, and Y is the amount that we get when we remove RP from the string. So, here we consider the example test case like this. So what is the amount 7 suggests? We will get amount 7 whenever we remove PR from the string, as I said, and we will get amount 8 whenever we remove RP from the string. So here we want to maximize the amount. So what will be the more preferable? More preferable will be what? 8. Why? Because this will maximize our amount. So how can we do this? So here we have here option PR and RP, which we will take. RP obviously. Why? Because we want to maximize the amount. So we'll take this RP and add it to our answer. Let's say answer variable is here 8. Now string will become PR, PP, TPPR. Okay. Now, what we will do? Now, similarly, we have option no RP is not available now. We have only option PR. So it is always better to take something rather than nothing. So obviously we will get cost 7. So we will take this cost and remove this from PR. PPTP. This will become answer will be added to 7 and this will become 15. So this is the maximum amount that we can get. So this is the question. So let's understand the question with an approach and thereby we will get intuition side by side. Okay. So now one thing that I want to clear. That means whenever we remove, it's like what we are doing. We are dynamically removing the character RP, string will become PPT. So other characters are joining. Other characters are joining in a string. So we can say we can use stack here. We can use stacker because we are removing characters dynamically. Stack, queue, these data structure apply for removing the character dynamically. If we use a string, so we have to go to every part and remove it, and that will become a really hectic task. So stack this provide this property push and pop in big of n. So that's better. So so whenever we want to remove consecutive characters, so we generally use the stack data structure. Okay. So now let's discuss the approach. With an example, we will get intuition side by side. So let us consider this test case, and we are given this test case, and we are given this x as 7, y is 8. That means cost required whenever we remove PR, we get a profit or amount is equals to 7, and whenever we remove RP, we will get amount or profit is equal to 8. We want to maximize the amount. Our aim is to maximize the amount. That means I have to get as many RP as possible. Okay. Now let's discuss with this example. Now we are at first index. We are getting P. What that means? That means we will add it here because stack is initially empty. Let's add it. Okay. Now we are at R. Now we are at R. Now we can see at the stack top we have P and here is R. So whenever R will come here, it will become PR. It will become PR. So is removing PR will increase our cost? No, removing RP will increase our cost. So we will say, let's add R as it is. Okay. You understand it, you will get the intuition at the end. Add R as it is. Why? Because if we remove PR from this string, from this stream, we will not maximize our cost. We have to remove as many RP as possible because cost will be more here. Okay. So now we have added P, we have added R. Now we came at this index, P. Now, P is here. Now, P will say, I will come here. If P will come here, so this will become RP. Obviously, removing RP will maximize our cost. So, we will, because 8 cost is here. So, what we will do, we will not add P. Instead, we will say, P, you should remain here as it is, and R, you should come outside. Why? Because you will maximize our cost. Okay, so R will come outside. This will become RP will be removed, and RP will be removed. So the answer will be 8 because on removing RP, we will get the cost as 8. So I'm again repeating like initially we have R and here is P. So whenever we add P, this will become RP. RP removing RP will maximize our cost. So we will take this 8 and remove this R from the stack. Okay. Now let's come to this index P. Now there is nothing. Let's add P as it is. Okay. Now we are at R. Now adding the R, adding the R here will become PR. So will adding PR will maximize our cost? No, because we have to get as many RP as possible. Okay, so we will say that add R as it is because we have to maximize the cost. We have to find as many RP as possible. So we will add R as it is. Okay, so we have done this. Now we come here. Now we are at T. Now here is the main point that we have to understand. Like when we are at T, so our stream will break. Why? Because if we are T here, so our stream will be this only, and we have to remove as many RP or PR as possible. Also, they should be contiguous substrings, na? So they should be contiguous. So that means this is a break point. So whenever any character other than R or P comes, like T is other character which is other than R and P, S, P, A, B, C, D, anything other than R and P comes. So we will say we have to check this out. That means let's say I came at T. Now, whenever I came at T, so I saw the stack and saw that here is PPR, PPR. So obviously we can see that here is PPR. So what we can do? Here stream PPR is available. Since we are not able to form RP, so it's always better to get something rather than nothing. Okay. Since we are not getting RP, so that doesn't mean so we will not take PR. Taking PR will also maximize the cost. It will give us 7. So we will add this and remove it from the stack. Okay. So now we have P. That will not make any sense because PR or RP is not nothing, not making anything. So we will say just empty our stack as it is. Now stack will become empty now. Okay. Now you will understand more at next iteration. Let's come to this P. Let's come to this P. Now add this P, I can say I will add this P. Okay. Now because stack was empty, let's add P as it is. Now let's come to this P. Now I will add this P as it is because RP or P or nothing is there. So I'll add P as it is. Now we're getting R. Now we are getting R. So R is here. R is here outside. Now P is here. Now R will say that if I will come here, will it maximize our cost? No, because PR will be 7. We have to get as many RP as possible. So we will say just add R as it is. It can be used at the end. Okay. So we will add R as it is. Why? Because if P will come here, so it will make it RP and we will get maximizer cost. So we will add R as it is. We will not remove anything. Okay. So now let's add this R as it is. Okay. Now let's add this R as it is. Okay, because previous character is R and next character is R. So no PR or RP is coming. So how can we judge this? Just add this. Now we are at P. Now we are at P. Now here is R. P will say when I will come here, I will make RP. And RP was maximum sum that I can get. So I will say add this to the answer. This will become 8. Okay. Now we will remove this R from here. P will not come inside. We will remove this R from here. Now Now I come to this P. I have done with this P. Now I come to this P. Now this P will say, if I come inside, that will maximize our cost. Okay. So I will say, okay. Okay. So remove this R. Remove this R. Remove this R and add this to the cost. 8. Okay. Now. Our iteration end. Now what we are left with this stack. Now you have to think some observation. Let's say I have X is equals to 8 and Y is equals to 7. So what is our main task? X was the cost for removing PR and Y was the cost for removing RP. So I will say that removing PR will be more good because I will get more cost. So whenever I remove PR, at the end, we remain with RRR, something like PPP. This is the thing that you have to observe. And for this case, because we were removing as many RP as possible, so at the end, we will remain PPP, RRR like that. Okay. So this is the observation that you have to understand that at the end, you will be remain with this stack. Why? Because we were removing as many RP as possible. So we will left with PPP because if next time P come, this R will take it outside. Okay. So we will say that we will left with these sequence. Okay. So what we will do with these sequence? What we will do? So now, let's say my last stack was that our iteration is ended. We are out of the loop. Now we can see here is PPR. So was removing PR was getting us cost? Yes. Yes. So it is always better to get something rather than nothing. So we will say that this PR can also be taken. Remove this PR and add this to 7 to the cost. So this is our cost. P is single, can take it, stack will become empty. So we will say our final answer is this. So 24 plus 14, that is 38. Okay. So what was the things? So let's say, let me repeat something. Whenever we are at PR, at stack and whenever we at R. And if removing PR will be y, will be x. Okay. So if x is greater, so I will remove PR. If x is smaller, I will not remove. So if x is greater, if y is greater, I will remove RP, because if I will remove RP and let's say y is greater, so obviously I will get greater cost. So this is the thing. Third thing that I want to know, let's say at the end this comes, or iteration end or any character that will make it non-contiguous comes. So we have to investigate the array when this non-contiguous or iteration ends. So we can observe this thing every time that whenever we try to remove RP, we will see it will remain PPPR. Why? Because always we are left with PR, because we will not remove PR. We will try to remove as many RP as possible. So we will remain with PR. Okay. So why this array, this tag will not become like this? Because if this comes, I will remove it. Okay, so this is the case. That's why whenever this type of sequence comes, so like this is the observation. If you run many test cases, you will get this observation. And obviously, it is pretty obvious that whenever we are removing RP, obviously in the stack we left with PR. Na? This is only the observation. So this is the observation that we have made. So this is all about the approach that we have done. So let's discuss the code. So initially we take a stack of characters because we are given a string. Now what we will do, let's consider the size of the length string. Now, initially for storing the answer, we will take long answer is equals to 0. Now we will traverse the string. Okay. And I plus plus. Okay. Now let's discuss it clearly. Now every time I have some option. If my stack is empty, what we are doing? Just add it, because I have no option. I can't check anything. Okay. Now, now I have one option, that if x is greater than or equal to y. That means removing, what that means? Removing PR is better than removing RP. So we will say whenever at top we will found P, means at first we will found P at top, and my current character is R. That means answer plus is equal to X. Maximize the amount of this P and remove the P from the stack, as I said. Now if it doesn't happen, let's say inside we have P, and we are coming with the, so we have some test case like inside we have P and we are R, we will take it obviously. But let's say inside we have P and we are P, take it. Or inside we have R, take it. Or inside we have R, inside P, I can consider it at last. Okay, take it. So our main aim is currently to maximize as many PR as possible in this case. So we will push it as this. Okay. Similarly for other. So this will be the case when x is greater than y. So we will say removing removing RP is better than removing what? PR. Okay, removing PR. So we will say if SC dot top is equal to R. So if first character is R and the second character we are coming what up with is equal to P, P. That means answer plus is equals to Y, because Y is maximum here, and we will pop out from the stack. Else in the other case, as I said, push it as it is. I have no option. Now here we're done with this option. Now, when was something like, let's say my character P and R are known. So here was a test case like when iteration was ending or we were getting T. So we have to consider rest of the characters. Okay. So as I said that whenever character is encountered, any different character is encountered in a sequence of PP, RPP, something like whenever resolve. So if X is greater than Y, that means I was removing as many PR as possible. Obviously PR, na? PR or RP? PR. So we were removing as many PR as possible. That means in the end of the stack, we will be having RRPP, something like that. Okay. When we have Y greater than X, then that means we were removing as many RP as possible. That means in the end of the stack, we will be having PPR or something like that. So we have to consider them as well, because it's always better to take something rather than nothing. So we will say that if S of I is not equal to R, and if S of I, if any character is not out of these two characters, so we will say that while until our stack becomes empty. We will do until our stack becomes empty. So what we do, like initially, so we have to consider some condition if stack is empty. Okay. So if our stack is not empty, then we will take these things. Okay. So we will say, let's take the top character. Why we are taking this top character? Okay. And let's consider like this test case. So whenever we are a top character, what that means? That means we will be having RRRPP. Whenever we have top character R, that means we will be having PPRR. We can consider it like X greater than Y, then it will be RRP. When Y greater than X, PPR. It's either which I am considering it from stack top. Okay. Now, some questions, some people can ask this question that if it is PPP, so what will happen? So let me tell you after the code, like cat CH is equals to SC top. Now, count R is equals to 0, count P is equals to 0. Now what we will do, while stack becomes empty, until stack will not become empty, we will say if SC top is equal to R, count R plus plus, else count P plus plus. Okay. Now we will add R, we will add P now. We will remove one. Now one thing that you have to understand. Now if top character is R, if top character is R, if top character is R, what that means Y is greater than X. Y is greater than X. So Y was taken. Now we have to take X. We will take something. Okay, so we will take answer plus is equals to X. Now how much I will take this X? So let's say I am considering three cases. P P P R R R. Second case P P R R R. Third case P P P R R. So here I can see I can remove PR, it will become PR. Okay, I can remove PR, it will become PR. So we have two PRs coming. That means X will be two times. Why? Minimum of both. P count was 2, R count was 3. So minimum of them was 2. So X into 2 will be the cost. Similarly here 3, PR, PR, PR. So will be 3 because minimum of them will be 3. Similarly minimum of them will be 2. So that we will say that we will add X into what? Minimum of count R comma count P. Similarly, if top character is equal to B, obviously it will be equal to B. We can also write it like this. So we will say answer plus is equals to Y into minimum of count R comma count P. Okay. So now what we will do? Obviously we will continue because we don't have to consider characters that T or something like that. Now, this is done. This is done. Now. At the end of the iteration, same thing can happen. So we will add this code, copy, and then just paste it here as it is. Okay. Now, what we have to do? Return the answer. So we return the answer. So let's compile and run the code. Okay. So let's submit the code. Yes, it is working fine. So at the last, I have to tell the intuition that whenever we were getting R, we have to, whenever we had P, whenever we have R, whenever we want to add P, so we were having RP, it will generate cos X. Whenever we remove PR, it will generate cos Y. We have to select those costs which will give us better. And at the end, if any of them P, P, R or something like left, we will take that as it is because it's better to take something rather than nothing. So this is all about the code. Yes, this code is very, very long, but when you understand this question, so it will be very easy to write this code. So this was all about code. So thank you and have a nice day.